Automatic transmission includes four main systems. Hydraulic torque converter, which connects the engine to the gearbox. Gear mechanism, which provides various ratios. Hydraulic circuit, which controls the servos and lubricates the system. And the final drive, which has the same function here as with a manual gearbox. Like the clutch on a manual gearbox, the torque converter provides a hydraulic coupling between the engine and the automatic transmission. This coupling is based on the principle of centrifugal force. To understand the principle of centrifugal force, take a container half full of oil. When rotating at a certain speed, the container imparts movement to the liquid it contains. Above a certain speed, the liquid is thrown out of the container. If vanes are added to the container, the phenomenon is amplified. The automatic transmission mechanism is made up of epicyclic gear trains. These are sets of gear wheels that provide different ratios according to the speed of rotation and how they are driven. This type of transmission has various advantages. Several ratios can be obtained from a single epicyclic gear train. There is no discontinuity when changing from one gear ratio to another. It can also transmit high engine torque. Now, let us look at how the epicyclic gear train works. To transmit movement from the input shaft to the output shaft, three components are required. A drive component turned directly by the turbine shaft. A reaction component, prevented from rotating to obtain different movement combinations. And an output component, connected to the output motion shaft. In an automatic transmission, each component of an epicyclic gear train can be a driving component or a reaction component or an output component. Clutch and brake units called hydraulic servos are used to control the various epicyclic gear train components. The hydraulic servos are of the oil bath multiplate type. Band brake technology is used for certain types of gearbox. It has the advantage of accepting higher torque and having less drag. A flow of oil under pressure, called line pressure, is used to operate the servos and lubricate the gear mechanism. The hydraulic distributor controls the line pressure to the servos by means of valves and solenoid valves. Applying oil pressure to a brake prevents a gear wheel from rotating by connecting it to the gearbox casing. It then becomes a reaction component. Applying oil pressure to a clutch causes a gear wheel to rotate by connecting it to the turbine shaft. It then becomes a driving component. One or more servos may be activated depending on the ratio required.